Hi, my name's Ethan, and I am doing quiz question revisions for the initials DE. And without further ado, let's get started with question 1 here on 24.6, 26.1. Solve the absolute value inequality and write the solution set using interval notation. So, right here we've got our absolute value, and whenever we got an absolute value, we have to account for two cases. If the thing inside the absolute value brackets is positive, so in this case, if x is positive, and what happens if it is negative? Great. So, in the case that it's positive, this really doesn't change. So let's write this in interval notation. So it's all numbers from not including 4, so soft bracket there, to infinity. And over here, we need to put this equation in terms of x so that x is only on, there's only x on this side, kind of like this one right here. So what we have to do is we have to divide by -1, but remember, whenever we are dividing or multiplying by a negative, we've got to switch the inequality sign, so that inequality sign is going to flip. We're going to get to this inequality statement, and we can write this in interval notation. So it's any values less than -4, not including -4. So that's going to be negative infinity to -4. And if we look at our answers here, it's going to be this one, which includes both of the two possibilities. Amazing. All right, let's go down to this one. So also from quiz 24.6, 26.1, this is question 2. Kind of the same thing, solve the absolute value inequality and then write the solution using interval notation. So again, we've got the two possibilities where the inside is going to be positive. So 6x minus 3. And what if the inside is negative? Make sure you put brackets around the entire thing, because I'm saying the entire thing in the absolute function is going to be negative. So let's solve the left one here. So this is going to be 6x. We can add 3 to both sides. We get 8. Then we can divide both sides. That's going to be 8 over 6. That reduces down to 4 over 3. If we write this in interval notation over here, that's going to be any values greater than 4 over 3, including 4 over 3. So you've got hard brackets here, square brackets, whatever you want to call them, to infinity. Great, and let's look over at the negative side here. So let's move that negative over to the other side. When we do that, we've got to flip the signs again. So that is going to be, it's going to be 6x minus 3 is less than or equal to -5. Then we can move the 3 over, add 3 to both sides. We get 6x is less than or equal to, that is going to be -2. Divide both sides by 6. -2 over 6 is going to be -1 over 3. Perfect. And I'll write it down here in interval notation. So that's any value less than -3. Any value less than -1/3, that including -1/3. So values from there. And then our square brackets. So if you look at our answers, it's got to include both of those domains there. And so it must be this one here. Okay, so this is question 2 of quiz 26.4, 26.5. Excuse me. So we got to factor this expression here. Now, for simplicity's sake, let's substitute. Let's just make up this variable a and say it's equal to b to the power of 12. So we are going to get 30 minus, or plus, excuse me, a minus a squared. It's starting to look a little bit more like something we're used to dealing with. And then I'm a big fan of having the leading degree term, this a squared in the front. So let's pull out a negative so we can make that possible. Minus 30. Perfect. And now if we were to factor this expression here, let's get our brackets on. We've got to find two variables that multiply together make a squared. That is going to be a. And now we've got to find two numbers that multiply to make negative 30, and that add together to make negative 1. Negative 1 there. Ooh, that is negative 1. So let's make a little chart here. 30, numbers that multiply up to 30, so that's 130, 2, 15, 3, 10. That is going to be 5, 6. Okay, so 5 and 6 is looking pretty promising, because if we make the, remember this has got to be negative 30, so one of these numbers, either one of these numbers in each of these columns has to be negative. So in this case, if we make the 6 negative, then that is going to multiply to make negative 30, and that's going to add together to make negative 1. So let's write negative 6 plus 5, and if you really wanted to, you could FOIL to double check we made the right thing. So firsts, outsides, insides, lasts, and you should get this equation up here. In this case, you do. Anyways, our next step is we want to substitute back in what our A was equal to, because in the answers to this question, they are in terms of B. So this is going to be negative 1, b to the 12, plus 5, b to the 12, minus 6. And right now, looking at our answers here, this is a lot looking like this one, this bottom answer here. And if you were to multiply this negative 1 by this expression here, you are going to get this expression here. So we know that our answer is going to be D here. All right, moving up to question 3 on quiz 26.4, 26.5. Again, it's another factoring question. So let's write out our brackets. We've got two variables that need to multiply together to make x squared. That's going to be x and x. And we're looking for two numbers that multiply together to make negative 8 and add together to make plus 2. So let's make a little chart here of numbers that multiply to make negative 8. So that is going to be negative 1 and 8, 1, negative 8, 2, negative 4, and negative 2, 4. Looking at this, these two numbers multiply and make negative 8, and when you add them together, you get positive 2. So those are going to be our numbers. But remember, we have these y's attached to it. Y is attached to each term. So this is going to be, well, we've got to have, so to put a y in this position here, we have to have two y's in the terms here. So we can write that out, y, y. And so then we can add our coefficients that we determined down here, these guys. So one of these has to be negative 2y. One of these is plus 4y. And again, you can double check, because if we multiply this through, do our FOIL, do our firsts, our outsides, our insides, and our lasts, we should return back to this original expression. And then looking at our answers here, it is going to have to be this one. Perfect. All right, last one here. It's going to be question 1 of 27.1, 27.2. Find all numbers for which the rational expression is not defined. So the rational expression, any rational expression is not defined when the denominator of the expression is equal to 0. And in this case, it doesn't look like there's any value for c that would make the denominator equal to 0, because the denominator is always going to be equal to this 5 here. So in this case, there are no values that will make this rational expression not defined. Thanks.